Hello Year 10 and welcome to today's lesson on factorising quadratic expressions. We did look at this a couple of lessons ago, but today they're going to get slightly more complex, and then next lesson we'll start to look at solving these more complex quadratic equations. To start today's lesson, can you go ahead and pause this video and have a go at these do now questions? Okay, before we go any further, I'd just like to remind you how we solve equations like this. Step one is always to factorise. When I'm factorising an expression that looks like this, I need two numbers that multiply to equal positive 32. And I need those two numbers to add up to equal positive 12. This is nice because it's all positive. I am going to be purely working with positive numbers. Factors of 32 could be 16 and 2, they could be 8 and 4, they could also be 1 and 32. The two numbers here that are going to add up to positive 12 will be 8 and 4. So that means when I factorise, I get x plus 4 and x plus 8. Now it wouldn't have mattered if you put x plus 8 in front. This still equals 0. Now, if I can make sure that one of these two factors is equal to 0, that overall means the total expression will have to equal 0. Any number multiplied by 0 will be 0. So either x plus 4 equals 0 or x plus 8 equals 0. Solving these, I get x equals negative 4 and x equals negative 8. Therefore, if I was to substitute either of these numbers into my original expression, they would equal 0. So these are the two values of x where this expression equals 0. Okay, I want to briefly look at the challenge question because some of you will have had a go at this. Now this is a quadratic expression. If I was to expand this, the highest term of x I would get would be x squared because I'd get 6x squared. I would also get negative 4 at the end. I'm going to get 3x. And I'm also going to get minus 8x. This becomes an expression that looks like this. 6x squared minus 5x minus 4 equals 0. So it is a quadratic. Yes, it does have a number here, a coefficient of x squared, but it is still a quadratic because x squared is the highest power of x. Now, if they've given me this, currently you don't know how to solve this because you need to make sure that you could factorise it and then solve it. This question here in the do now though, they've already given you the factorised form. So I just have to set each factor equal to 0 and that will give me the two values of x for where the total expression is equal to 0. So we get either that 2x plus 1 equals 0 or that 3x minus 4 is equal to 0. Solving these are two-step equations. They'll take a little bit longer to solve, but I can subtract 1 from both sides on this one to get 2x equals minus 1. And then divide by 2 to get that x is equal to minus a half. Yes, you could write negative 0.5, but a half is perfectly acceptable too. For the one on the right, I want to add 4 to both sides, which gives me 3x equals 4. And then I need to divide by 3, which is going to give me x equals 4 over 3. This one I would definitely leave as a fraction. If you turned it into a decimal, you're going to get 1.3 recurring. It's just not such a nice answer. Leave it as a fraction, it's much more accurate. Okay, I'm going to reveal the rest of the answers now so you can check the other questions for yourselves. Okay, and can you please pause the video here and write down today's date, title, as well as the keywords. Okay, so last time we looked at factorising and also solving, we didn't have what we call a coefficient of x squared. A coefficient is the number that we're multiplying another number by. Okay, it is stuck to it. It's the coefficient of x squared. We did look where we had a coefficient of x. We were quite used to having a number in the middle. And we were also used to having a number at the end. It's just a number on its own with no x terms. Okay, today we want to look at how to solve things that look like this. Well, tomorrow that's what we'll be looking at, but for today, I need to make sure that I can factorise. Now, this is in the format of ax squared plus bx plus c. The coefficient of x squared is always referred to as a, and that's going to come up time and time again as we progress through this module. The coefficient of just x is always known as b, and this number on the end is known as c. Now, you'd have seen that plus c before when you looked at linear graphs and you had y equals mx plus c. It actually means the exact same thing. It does also refer to, if this was an equation rather than just an expression, that would also, just as it does here, refer to the y-intercept. This one would be a straight line graph, and this number here would be c. And this one here would be some kind of curve, and this number here would be c. It's always the y-intercept. But for now, what you need to write down into your books is that this is the general equation of a quadratic. Okay, so when we are factorising things that look like that expression on the previous slide, we need to follow these steps. For now, these steps may not make a lot of sense to you, but I'd like you to write them down into your book, and we're going to go through step by step solving some of these questions. Okay, so we're back with that original expression that we had. Step 1 said find AC. Now AC is a multiplication of A and C. So I first need to know, well, what is A? Well, that's the coefficient of x squared. It's this number here. So A is 2. And I also need to know what C is. C is that number on the end. It isn't a coefficient, it's a constant. Okay, C is equal to 15. Now these numbers are both positive. So I'm not going to write them down because a number without a sign is suggested to be positive. So finding AC, AC is equal to 30. So that's step 1 done. Step 2 says find the factors of AC. So that means I want factors of AC. I want two numbers that multiply to equal 30. I want factors of AC that sum, that add up to B. Well, B is 11. Okay, it's the coefficient of x. So B is equal to 11. So I want two numbers that multiply to give me 30 and add to give me 11. We could have 1 and 30 as factors. I'm going to put them in brackets so we can see them separately. We could have 6 and 5. We could have 2 and 15. And I've already realised I could find more, but I'm going to stop. 6 and 5 will add up to 11. So that's step 2 done. Step 3 says separate bx. Into two terms using the factors of AC. That means I'm going to use these two numbers and I'm going to rewrite the expression, but instead of having bx, this 11x, I'm going to write it separately as two terms. It's going to be 6x and 5x. So I'm going to have 2x squared plus 6x plus 5x plus 15. Now this is still the exact same expression as the one above, but this is simplified because I've combined like terms. I've just separated them out here using these factors that I found of AC that added up to B. So I've done step 3. Step 4 says factorise them in 2 halves. That means I'm going to separate it into 2 sections. So I split it into half. I've got 2 terms on each side. And I now want to factorise each of these. Looking at this, I've got an x term that I can factorise out of both of these terms. And I've also got the number 2 because I can take a factor of 2 out of 6. So I'm going to have 2x, and in my brackets, 2x times x will give me 2x squared. And then I'm also going to have plus 3. 3 times 2x will give me 6x. Then I need to factorise out the other side. I can factor out a 5 from both of these terms. So I'm going to factor out 5, and I'm left with x plus 3. Now notice, these two brackets are the same. That should happen. If they look different, you may need to look at your factorisation again. They should look the same. Finally, that was step 4. That was factorising 2 halves. Finally, step 5 says write into brackets. So one of my brackets is going to be the bracket I already see. So that's x plus 3. So that's the first bracket. And the second one is going to be everything that's left over. So I'm going to have 2x and plus 5. Now, if you wanted to at this point, I'm going to run out of room, but you could expand this again and check that you get your original expression. If you do, then you know you factorise correctly. And I would recommend doing that in an exam-based scenario, is expanding it again to double check your answer. Okay, please pause the video here and make sure you get this down as a fully worked example. Okay, one more example I'd like to look at. This time I'm not going to write down the steps, I'm just going to say them. But you can compare it to the previous example to see exactly what I'm doing at each step. So first I want to find AC. AC is going to be 5 times negative 14. And that negative is important. That is going to give me negative 70. And I want to find factors of AC that multiply to give me AC and add to give me negative 33. That's B there. So I want factors of AC. So I want them to multiply to give me AC, but add to give me negative 33. Now, because this term here at the end of AC is negative, it's also negative here, that means one of my numbers is going to be positive and one of them is going to be negative. I want them to multiply to give me negative 70 and add to give me negative 33. So we could have 1 and 70. We could also reverse these and we could have 70 and 1. Alternatively, I could have positive 35 and negative 2. Or I could reverse these and have positive 2 and negative 35. These two terms here are going to add up to give me negative 33x. So it's these ones that I want to use. Step 3 says separate bx, that's this term here, into two terms using the factors of AC. So I'm going to separate it using these. Now I'm going to choose to put the negative 35 first and the 2x second. That is because I immediately saw negative 35 and 5x and thought, well, I know I can factor out 5 there, so I'm going to put that first. It wouldn't have mattered. You could have put this 2x first. Just would have had a slightly different method as you went through, but you would still get to the same answer. Now I need to factorise in 2 halves. That is step 4. So I'm going to split it into 2. I can factorise out a 5 from both of these as well as an x. So I'm going to have 5x. And inside the brackets, I will be left with x minus 7. And for the one on the right, I can factorise out 2 from here and also from here. I'm going to factorise out a positive 2, leaves me with x minus 7. Now that this bracket is the same, I know that I've gone right so far. And finally, I need to write into brackets. So I've still got x minus 7. And then I've got 5x plus 2. Again, if you were to expand this again, and get this answer up here, then you know you've factorised correctly. Please pause the video here and write this down as a further worked example. Okay, and can you please have a go at this one on your own? In a few moments, I will begin to solve it silently so that you can check your working. Okay, I just want to discuss this one briefly because there's a few things you may have noticed that came up. Firstly, you wanted two numbers that multiplied to give me positive 18, but added up to give me negative 11. That means the two numbers are going to have to be negative. So that's why I immediately started writing down pairs of negative numbers that multiply to 18. That way, when I add these two up, I'm going to get negative 11. So I chose negative 2 and negative 9. I then separated that out over here. I put the negative 9 first because when I looked at the 6, I realised that I could factorise out 3. You could have equally put that negative 2 first, just so you'd have a slightly different step here. At this point, I factored out of this half 3x from both terms, which left me with 2x minus 3. And for the one on the right, I realised that there wasn't much I could factorise out. However, I wanted the bracket to look identical to this one. If I factorised out negative 1, so if I wrote negative 1 here, I then worked out, well, what would I need to multiply negative 1 by to get each of these two terms up here? Well, it would be 2x. Negative 1 times 2x would give me negative 2x. And negative 1 times negative 3 would give me positive 3. So although there wasn't a physical number that I could factorise out, I just factorised out negative 1, which made each of these the reverse operation. That then gave me an expression with two brackets that were identical, so that became my first bracket, and then my other one was the two terms left over. Okay, can you please pause the video here and have a go at these questions and come back to have a look at the answers when you're finished. Okay, here come some of the answers. Okay, you have come to the end of today's independent practice and learning. Please make sure you take a photo of your work and upload it onto Frog, as well as completing the online quiz. That is how we're going to be able to check that you've understood today's lesson.